chapter 601. In POTS chapter 601, the only import that is needed for that chunk is the pandas. It reads the data into an object called data frame. So whenever you see the df, it's a data frame, it's a pandas data frame object. For example, here, everywhere you see df, it's a pandas data frame object. Here we're going to see reading and writing data in text format. Example A takes the file from there called ex1.csv, comma separated values, and it simply prints it. Now let's see what's actually in that ex1.csv file. It's a simple file. It has a header here and 1, 2, 3 lines of data. This first line is going to become the headers of the columns for those 5 columns, column 1, 2, 3, 4, and 5. So the header for column 1 is A, the header for column B is, the second column is B, and the header for the last column, which has the words hello, world, and food, the header is message. They are separated in the file with commas. So let's see what that one does. I'm going to run it. And it's going to be example A, the first one. And go up, does it run everything? So example A prints the file, as we saw it. A, column A, column B, column C, column D, and the last column called message. So this right here, pandas takes the first row and converts it into the headings. It uses it and converts it, formats it to the headings of the columns, right? Everything separated by a comma becomes a column, and pandas also adds indexes to the data columns, not to the header. So that 0, that 1, and that 2 were not in the file, as you see. They are added by pandas. And so we have a nicely formatted little data frame. The function to do that is pd.read_csv, and the package of the file. It goes into this df, and I just printed it and printed another line below it. In example B, what we see is that the file to be processed into the data frame is called ex2. Let's see what's in ex2. Let me turn it down. Okay. In ex2, we have a file. Again, it doesn't have a header. I mean, in this instance, it's just this data lines. It doesn't have the headers for the columns. So we're going to have 3 rows of 5, each of 5 columns. And the code says header is none, for example B. In example B, we see then that by putting header equals none, telling me, okay, this file doesn't have a header, pandas by default puts the header like this, 0, 1, 2, 3, and 4. And again, it also put the indexes for the actual rows, 0, 1, and 2. Notice that we have different kinds of things here. We have numbers and words. Okay, example C. Example C uses the same file ex2, but in addition to saying, okay, my file, my comma separated value doesn't have headers, by saying header equal none, I'm going to use these headers, 1, 2, 3, 4, 5, 5 headers. Column A, column B, column C, column D, and the last one, which is one that has the words hello world foo, the column is going to turn out to be a column header. Same thing, pd dot read underscore cdf. With this notation, pd dot is using the object pd, and it's one of its methods is called read csv. So in example C, we see that the headers that we use here by using this argument, names equals bracket, this parenthesis is the function parenthesis. So this bracket here, and that bracket delimit the column headers. Call A, call B, call C, call D, and a column header. Again, the indexes on the left here are produced by pandas as well. In example D, we're going to still be using the same ex2.cds comma separated value, which doesn't have a header. And we're going to do an assignment for the columns into a variable. The variable names is now going to contain the column headers A, B, C, D, and my index. So naturally, these will become the column headers for our columns. Again, pd.read underscore cds. Here is where we, instead of saying names and actually put the names there, we're going to use the variable names that contains the column headers. And we're going to do something new, which is index underscore column. It's going to be called my index. Let's see what becomes of that. This is example D. We see, cool, the A, B, C, and D became the column headers, but because we said that the last one here in our list of names for the columns is called my index, I said I want you to use that one, my index, to name the index that pandas forms on the left. And instead of this 0, 1, and 2 that we had seen before, now pandas is going to use this header and the last column, because of the order here, as an index. So now the last column in our file that had the words hello world and foo actually became the leftmost one, and it is the index now. Hello world and foo is our indexes. In the video, the good thing is that you can rewind it, you can stop it, and you can try to recreate it and so forth in your own machine. Let's see example E. In example E, we're going to be again creating a data frame with the same function, but with the file csv mindex.csv. Let's look at that one. CSV and index. This one here. Okay, so here we have a comma separated value file that has as its first line the headers for our columns, key1, key2, column 1 and column 2, separated by commas, and our data. So it's 1, 2, 3, 4 values, 1, 2, 3, 4 values. Okay, everything has data. The first column repeats 1, 1, 1, 1. The second, then it repeats 2, 2, 2, 2, and then we have A, B, C, D, A, B, C, D, and then numbers. Let's see what pandas does with that. When we call it with saying, okay, I want you to use key 1 and key 2 as indexes in that order, and the order matters. We'll change those so you can see. Remember, we have key 1, key 2, column 1, column 2. Let's see what it does. Okay, it's done. It's example E. You see, it took key 1 and key 2 and made key 1 an index and key 2 also an index. But because the index repeated 1, 1, 1, 1, 2, 2, 2, 2, pandas only printed the first whenever it changes. The key 2 is like that, and our data. What happens, I wonder, if we change the order of the indexes here, say key 2 and key 1, change the order, let's see what happens. And that is example E. Okay, there you go. Now, key 2 appears on the left. What's the second column? It is the second column in our index, and key 1 became the second index here. But because there were no duplicates, at least consecutive duplicates there, we get all the values that we have. I'm going to change that back to the way it was. Okay. Now let's see example F. Example F uses ex3.txt, which really shouldn't make a difference if it's comma separated. But if it's not, then you should name it CSV. And this one is not comma separated. ex3.txt is actually separated. The data elements in the rows, the columns, are separated by spaces. So instead of using panda.read underscore CSV, we're going to use panda read underscore table. It is a data frame anyway. So let's see example 3.txt. Oh, txt, I'm sorry. Example 3.txt. Where are you? Example 3.txt. So this file is not a comma separated value file. Obviously, the items are separated by one space. It has 3 columns and 4 rows. And this is in the data. This is not produced by pandas. So let's see how that one goes. It's example F. Example F. And we see the file nicely there. Pandas did not add an index on the left. It did not do anything to the file. It just, in this case, printed it nicely. Here we've indicated that the separator is however many spaces. Let's see example G. This one uses, again, a comma separated value file called ex4. Let's see ex4. ex4 has a row that is the headers for the columns, A, B, C, D, and message. A is going to be 159 and so forth, and the last column is going to be hello world full with the header message. So let's see what pandas does. The little thingy that is introduced in this example is the argument called skip rows. In this case, we're telling pandas, okay, I want you to skip row 0 and row 2 from the result that we're going to put here in our data frame. So if we're not going to see, we should not see the row 0 and row 2 of ex4. Row 0 is the headers, and row 4, 0, 1, 2, 3, 0, 1, 2, row 4, row 2, I'm sorry. 0, 1, and 2. So we should not see the one that has the word world and those numbers in the result. So that's example G. Example G did indeed show me only 2 lines, the one that has hello and the one that has full, which is the 1 and the 3. So it did skip 0 and 2. Right on. Example H. In example H, it's using comma separated value EX5. That's EX5. These are the headers for the columns. They're all numbers. And we have 3 rows. The interesting thing, if you notice here, is that we have a value called not available or non-applicable as the last value, the first one for column 6, the last one for row 0. Notice in row 1 that we have comma, comma. That means that we're missing a value in there, right? And in the next row, we have the word full in the end. Here, what we've done, and this is the last example for POPs chapter 601, example I. These are called sentinels. You create sentinels as a dictionary. These brackets define the context here as a dictionary with a key colon definition, comma, key colon definition. If there's more than one definition, you put them in brackets and put a comma between them. What this is going to do is it's going to say wherever you find under column 1, a data element that says 2, and also under column 6, if you find anything that says full or anything that says NA, those are non-applicable values. So Pandas is going to convert anything under the column 1 that says 2 to NA, and anything under the last column, column 6, that says full or N/A, it's also going to convert it to NA. This is important because you're going to find data that's missing stuff or that has little glitches like that, and you can write them into sentinels and standardize them as not a number, NaN, in Pandas. That is example I. Example, oh, there was something else. Okay. Example I. Notice that under column 1, after the number 1 there, Pandas put an NaN. Let's see what was there. One. Is that example 5. Under column 1, if you find the 2, okay. You see this 2 here? I said no. That's an indication that that's not applicable. So Pandas put an A and N there before the 5. You see. I also said if you find the word full or NA in the last column, remember? So we have an NA here and we have a full. Those I want you to standardize to not a number, or not a number there, and last. So that's the last example using Sentinel's dictionary with one or more values to standardize bad data or missing data in our file. Just to let you know, I did 9 of these files. So we're going to be seeing a video of other chunks of that chapter 6 code. Hello.